Hello, this video is for Algebra 1, and today we'll be talking about how to simplify expressions. Okay, so let's talk about simplifying expressions. Usually in Algebra 1, we come across two different types of expressions that need simplifying, and this is one of them. This will simplify using a method called combining like terms. So what we want to look for here is any like terms that we can combine. And a like term is something that's being added or subtracted that has the same variable to the same power, or no variable at all. So what we're going to do here is go through here and see if we can identify the terms that are like each other. So -3 is an integer with no variable. So that is a term that is like -3, which is also an integer with no variable, plus -7, which is also an integer with no variable. Now, I didn't underline the 8p because the 8p has a variable. So that is not considered to be a like term with the other three terms I've underlined. So if we're going to combine these like terms to simplify the expression, that means we're going to go ahead and complete those operations. Let's start with -3 minus 3. When we do that operation, we end up with -6, and then I'll rewrite the plus -7 because we haven't done that yet. Now I'll complete this operation. If I have -6 plus -7, that equals -13. So those three terms combined together is the same as -13. Now I'm just going to go ahead and bring down the plus and the 8p because I don't have anything else in this expression that I can combine the 8p with. There's no other terms that have p to the first power or to no power at all. So this would be my final answer when I'm done simplifying. It would be -13 plus 8p. Another way that I could write this expression is I could flip the order. I could put the 8p over here, and then I could write -13 to represent the -13. I could also write plus -13. As long as the terms are the same, with the negative being in front of the 13 and having a positive 8p, you can write it in any order that you want. Okay, let's look at the other type of simplifying we do most often in algebra, and that is using the distributive property. So we use that when we see in an expression or an equation that we want to simplify, where there's a number outside the parentheses with nothing in between the number and the parentheses, just like this one. This one has 5 parentheses, 5j plus 4 end of parentheses. So that means 5 times 5j plus 4. So how we simplify this is we use what's called the distributive property, where we multiply the 5 times on the outside by each term inside the parentheses. So we're going to multiply the 5 times the 5j and the 5 times the 4, and then we're going to rewrite that. So 5 times 5j would be 25j. I'm going to keep the plus in between, and then 5 times 4 is 20, and then I still have a plus j out here. Okay, so now that I've used the distribution property, now I can see that I have two like terms I can combine as well. So I'm going to go ahead and underline the 25j and the j as like terms that I could put together. Well, 25j plus j gives me 26j. So that's going to take care of the j's, and I can cross that off. And then I'm going to put the plus 20 because we haven't done anything with that, and there's nothing for us to combine it with. So your final simplified expression here would be 26j plus 20. Okay, so let's do some practice problems with this. Here's our first one. It's 4 plus 9g plus 4 plus 2. So first thing I want to do is go through here and underline or identify my like terms, because I don't see any parentheses, so we won't be using the distribution property here. I see a 4. Oh, that's a little light. Let me pick a different color. I see a 4, another 4, and a 2. All of these terms are integers that have no variable, so I know I can put those together. 4 plus 4 is 8, plus 2 is 10. So when I combine those together, I get 10. If I want to, I can cross them off, so I know that I've already combined those with something else. And then all I have left is 9g. There's no other terms with a g to the first power, so that means I'm just going to rewrite that into the expression and not combine it with anything. My final answer here would be 10 plus 9g, or I could flip it around and make it 9g plus 10. Okay, so here's our next one. We've got -8 times -2f plus 4. Okay, so this one does have parentheses, so that means we can use the distribution property here, which means we'll multiply the -8 times the -2f and the -8 times the 4 and keep that plus sign in between, maybe. We'll see. Okay, so when I do -8 times -2, I end up with positive 16. So I'm going to write 16f as my first term. Then if I do -8 times times positive 4, I end up with -32. Now there was a plus in between, so I'm going to keep that there. And now I'm looking at it though, adding a negative is the same as subtracting. So maybe I can rewrite it as 16f minus 32. So either of those is correct, but if you want to leave the 16f plus the -32, maybe wrap that -32 in parentheses so we don't read it as something other than adding a negative. So those are the two options we have here after we simplify. Okay, here's our next practice problem. So we see here some parentheses, which means we're going to be using the distribution property. But we also see some stuff outside this parentheses, so maybe we're going to be using more than that. But let's start with the distribution property first. So we're going to multiply 7 times the 10y squared and 7 times the 5y squared. I'm going to go ahead and rewrite the 4y squared right here. Now there's a plus in between there, so I'm going to keep that there. 7 times 10 is 70, so I'm going to rewrite that as 70y squared. And then 7 times 5 is 35. So I'm going to keep that plus sign and write 35y. Okay, now we can go through and look for like terms. Now remember, like terms have the same variable to the same power. So even though all of these have y, only 2 of them are to the second power and 1 of them is to the first power. So I cannot combine the ones that have the second power to ones that have the first power. That will not work. But I can combine these two because they both have y to the second power. So if I put 4 plus 70, I end up with 74. And then I'm going to rewrite the y to the second power. And then maybe I cross those off to show that I've already combined them. Now I cannot include the 35y or combine it with the 74y squared. So I'm just going to go ahead and put plus 35y. So this is what our expression would look like when it's simplified. Okay, here's our next one. 7k squared plus 6k squared minus 9k squared. Okay, so I don't see any parentheses here, which means we're probably not using the distribution property. And it looks like all 3 terms have k to the second power, which means we can combine them all together and simplify. So I'm going to start with these first two. 7 plus 6 is 13. So I'm going to rewrite this as 13k squared minus 9k squared. Now I can deal with this because this is the only one left to combine. 13 minus 9 is 4. So I'm going to go ahead and put 4 here. And then I'm going to rewrite the k squared. So this simplifies all the way down to a single term, which is 4k squared. Okay, here is our last one for this video. So we are going to be simplifying 6a squared minus a squared minus 5a squared. Okay, so again, looking at this, I don't see any parentheses, so I don't see any use of the distribution property here, but we do have some like terms. All 3 of these terms have the same variable to the same power, a squared. So I know I can combine them all together. I'm going to start with these two, 6a squared minus a squared. Now, even though there's no number in front of a squared, there's that invisible 1 that's always there in front of a variable with no coefficient. So 6 minus 1 is 5. So I'm going to make that 5a squared, then minus 5a squared. Well, we know that anything minus itself is equal to 0. So my final simplification of this expression is 0. Even though I don't know what a is equal to, I know whatever it's equal to, this expression is going to be equal to 0. All right, well, thank you so much for joining me, and then I hope to see you in the next video.